Hello everyone, welcome to Virtual School. Physics is fun. Wan Liao here. Alright, today we are going to look at reflection of light. Okay, now what is reflection? Reflection will take place when light strikes an opaque. Opaque means not transparent, not transparent surface. So light will be bounced off. Right? So this bouncing off of light is called reflection of light. When does it happen? When light strikes a non-transparent surface. Okay, so you can see here, the light that's moving towards the surface, the opaque surface is called incident ray, and the light that bounces off is called reflected ray. According to law of reflection, the incident ray, normal, and the reflected ray, they are all on the same plane. They all lie on the same plane. Normal means it's an imaginary line that is 90 degree to the surface. Okay, so incident ray, normal, and the reflected ray all lie on the same plane. And the second statement of law of reflection is the incident angle equals to the reflected angle. What is the incident angle? Incident angle is the angle between the incident ray and normal. I, this is the incident angle. And reflected angle will be the angle formed between the reflected ray and normal. And we call it R. So I equals to R. Alright, so you see the incident ray is here, the reflected ray is there, normal is here. So this is the incident angle and this is the reflected angle. So if the incident angle is 42 degree, the reflected angle will also be 42 degree. Okay, law of reflection. Right? Now, we are going to look at reflection of light when the surface is straight, plane, or a curved surface. So the best example would be by looking at a mirror, right? So plane mirror and curved mirror. Okay, let's look at plane mirror. Every morning you look at yourself in the mirror and you see your image. So, but how is this image formed? Okay, to know how the image is formed, so first we must learn how the rays are reflected. Right, let's take the candle as an object. So draw an incident ray from the object to the mirror. Then next, draw a normal. Normal is a line where it's 90 degree to the mirror. So with that, we can determine the incident angle, I1. By following the law of reflection, we know that I1 will be equals to R1. The incident angle will be equals to reflected angle. So with that, we draw the reflected ray. You can repeat this with another pair of incident ray and reflected ray. Right? So draw another incident ray from the object. Normally we draw from the same point, but at different angle. So draw this. So it forms the I2 here. And this is a normal. And with the law of reflection, we know that I2 equals to I1. So we draw the reflected ray. So these two reflected ray enters the eye of the observer. But image is formed at the intersection of the reflected rays. So these two reflected rays does not intersect here. In fact, it is diverging. So where do they intersect? To get their intersection, so we trace them back into the mirror. So you draw dotted line because they are not the real ray. They are rays that is inside the mirror. Rays actually cannot go inside the mirror, right? That's why it this imaginary lines. So we draw dotted line. So you see that these two reflected ray meet, they intersect inside the mirror. So this is where the image is formed. Right? So the image of the candle, it is inside the mirror. Alright, so this is how image is formed. Image is formed at the intersection of two reflected rays. Okay, what is the characteristic of this image? So you can see that the image is upright. It is virtual. Virtual means it is not formed on the screen, right? We will see what's the meaning of virtual much more later on, yeah? So it is virtual, it is upright, it is same size as the object, and laterally inverted. So you see the right of the object becomes the left of the image. And one more very important point is the distance between the object and the mirror is the same as the distance between the image and the mirror. So D1 equals to D2. Alright? So the characteristic of the plane mirror, image of plane mirror is virtual, upright, same size, laterally inverted, and D1 equals to D2. Same distance from the mirror. Let's look at one question. Look at this diagram. You are given this angle 42. How much is the incident angle? Is it 42? Is this the angle of incident? No, right? Yeah, angle of incident is the angle formed between the incident ray and the normal. So it is theta 1, right? Theta I or theta I here. Okay, how much is theta I? So it is 90 minus 42. So you get 48. And how much is the reflected angle? Angle of reflection. It is the same as the angle of incidence. So therefore it is 48. Okay? Alright. What about this question number 2? So I have this mirror. This is a mirror. This is the incident ray. So the incident ray forms 50 degrees with the mirror. So how much is the incident angle? Of course, incident angle is not 50 degrees, but incident angle is the angle between the incident ray and the normal. This is the normal of the mirror. So it will be 90 degrees minus 50. So it's 40 degrees. Now, the mirror is now rotated anti-clockwise. You see this mirror, now I tilt it anti-clockwise 10 degrees. And the incident ray, no change. So what happened to the incident angle? The angle of incident. Is it still 40 degrees? So to determine the incident angle, the new incident angle, so we must know that when we tilt the mirror, the normal also change, right? Because normal is always 90 degrees to the mirror. So now this dotted normal is the new normal because the mirror is now this position. Yeah, this dotted line is the new position of the mirror. So the dotted line is the normal of the new position. So you see, the old normal was here. So now the new normal has moved, it has moved 10 degrees into the incident angle. Therefore, the incident angle now is from incident ray to here. So how much do you think is here? It was 40. Just now from here to here was 40. So now this is 10. Therefore, the incident angle, the new incident angle is only 30, right? So if the incident angle is 30, the reflected angle will also be 30. So this is 30. You understand? Right? Originally, this is the incident angle, which is 40. So now you turn the mirror anti-clockwise 10 degree. So this is the new normal, which move into the incident angle 10 degree into the incident angle. So now the incident angle is from normal to incident ray, which is only 30. So this 30 plus 10 was 40. So now the new incident angle is only 30. Right? So 30 incident angle, reflected angle will also be 30 degree. All right, understand, yeah? Okay, so we will stop here. We will continue with curved mirror in another session. All right, bye-bye. Thank you.